Alright, Unit 7 Notes 3, Combinations, Learning Target. I can use combinations to determine the number of outcomes for a given situation. A basketball league has 5 teams. 2 of the teams are chosen to play one another. How many different possible matchups are there? So if I have 5 teams, A, B, C, D, E. Okay, first off, A needs to play B. Team A needs to play C. Team A needs to play D. Team A needs to play E. Then we go like this. Team B needs to play A. Team B needs to play C. Team B needs to play D. Team B needs to play E. Then you have Team C. C plays A. C plays B. C plays D. C plays E. They can't play themselves, that's why we don't say C plays C. D plays A, D plays B, D plays C, D doesn't play D, that's what I was getting at, so D plays E. And then last but not least, E needs to play everybody, so E plays A, E plays B, E plays C, and E plays D. Now I need another color, so I'll grab one here. I'm thinking like an orange. Alright, so here's what we got. A plays B. A plays B here, but it also plays A, B there. So we're going to cross that off. Right? The order of the game doesn't matter. Right? That's why we're not doing a permutation anymore. This is called combinations for a reason. We're learning something new. Alright? So you actually cross BA off because that game already happened. Alright? We can look at this one too. AC. Right? We can cross CA off then. Right? That game already happened. We don't need it to happen twice. Same here. A to D, D to A. A to E, E to A. So all those get crossed off because we've already played that game. Right? Then you can go up here. BC. Well, check this out. CB is right here. Right? Now we'll get B to D. That row crosses off. B to E. That game crosses off too. We just work our ways down the line. C to D, well, DC doesn't need to happen then. C to E, well, then EC doesn't need to happen. DE, ED. So then, how many games actually need to be played so everybody gets to play each other? 4 plus 3 is 7, plus 2 is 9, plus 1, 10 possible matchups. So it's Mr. Hoopert, as you can tell from the lovely voice. This is one of a kind and unique. So we're working on this combination. It's new. The order doesn't matter. The game just has to be played. It doesn't matter in what scenario. So how many different possible matchups? There's 10 different ones. So in permutation, the order matters. And combinations, the order is not going to matter. So looking at this next slide, combinations, right? A grouping or listing of objects in which order is not important. So you're going to have to decide now, does order matter or not? So this is very similar. We're going to have C for combinations. Remember, permutations is PR. However, permutations is in. I'm not going to write it there. I'm going to write it over here. Remember, permutations is in over n minus R. So this one is a little bit shorter. This is permutations. So there's a difference. Whether or not you're dividing by this extra R is the difference. So in order matters, you have less possibilities or more ways that it can happen. And so let me just show you. All right, so let's practice evaluating a few of these. 6 is in. So I'm going to go 6. Then we got 6 minus 2. Then we got a 2. So now I evaluate that. That's 6 factorial, 4 factorial, 2 factorial. 6, 5, 4, 3, 2, 1. 4, 3, 2, 1. 2, 1. So these are multiplications. My handy dandy marker here tells me 4 divided by 4 is 4. 3 divided by 3 is 3. 2 divided by 2 is 1. Ones don't matter. Alright? So all those cancel. This one cancels. This 2, I would take 6 divided by 2 is 3. So 3 times 5 is 15. That's all you're doing. Now it's very similar to what we were doing before. So I'm going to do this one a little bit different. So C8, by different it starts the same. 8 minus 3, little parentheses, and then you got 3 again. So I look at this, I see 8 factorial, 5 factorial, 3 factorial. So what that means is 8 times 7 times 6 times 5 factorial, all over 3 times 2 times 1 times 5 factorial. So what I did is a little trick where I'm supposed to go 5, 4, 3, 2, 1, 5, 4, 3, 2, 1, but I know that these are going to cancel. So then what I'm left with is 1, that doesn't matter. 3 times 2 is 6, so I'm going to go 2 for 1 here. Cross off the 3 and the 2 and cross the 6. 8 times 7 is 56. So the evaluation of this is 56 ways or whatever we're doing in this problem. Right? So usually with combinations there's a lot smaller numbers because you're dividing by more things. So looking at this, a group of 7 seniors, 5 juniors, and 4 sophomores. So 7, 5, 4. I have volunteered to be peer tutors. Mr. Picard needs to choose 12 students out of the group. How many ways can the 12 students be chosen? So does it matter how many juniors or seniors or sophomores we have? No. What we need to find out is 7 plus 5 is 12 plus 4 is a total of 16 students. So we need 16 choose 12. So now we got 16 over 16 minus 12 and 12. Now usually what I do is I go 16 times 15 times 14 times 13 times 12 factorial, because this is 16 factorial, 4 factorial, 12 factorial. So then I probably would have went like this: 4, 3, 2, 1, 12 factorial. The reason I always pick this one is 12's bigger than the 4. So 12's going to cross more things off. So this 12 here is going to go all the way down to 1, but we're just going to cancel right there. Now also we got this 3 in here. 3's go into 15 5 times. And then I probably would have went with the 4 into the 16. 4 times 4 is 16. And I'd even divide the 14 by 2 to get 7. So 4 times 5 is 20. Times 7 is 140. Times 13. And 140 times 13, I grab my calculator. And I get 1,820. 20 ways. They want to know how many ways. So that's what you're doing, all right? You're dividing by an extra thing in combinations, all right, because then there's a lot less possibilities. So looking at this, you and 6 friends are going to eat lunch. So you people, hold on. Uh-oh, it got cut off. Is it the picture? All right. So it says you can bring 2 people with you. So we're bringing 2 with. All right? Here's the important part. You are going no matter what. So don't count yourself. You're going either way. It's the 6, and you get to choose 2. So it'll be 6 choose 2. So I go 6. 6 minus 2. 2. Don't forget to divide. So I would have said 6. 4, 2. First, I would stop there. 4 is bigger. So I would have did 6 times 5 times 4. All divided by 4, 2. 4 cancels, 4 cancels. 30 over 2. If you don't want to divide it, reduce by 2. This is 15 ways still. All right? So you got to pick between you and your friends. Next one. Gym coach selects a team of 4 athletes from 14 athletes. All right, so we need Selects a team of 4 from 14. At a track and field meet, find the number of teams. Nothing mentioned about certain things. So 14, we need to choose 4, so we're going to do 14 minus 4, and then a 4. So this equals 14, 10, 4, 10's bigger, so I always just do 14 times 13 times 12 times 11 all over 4 times 3 times 2 times 1. If you want to write times 10 factorial and times 10 factorial, you can, but I get lazier and lazier as the video goes on. I know those are going to cancel. Look at this, 2 for 1. 4 times 3 is 12, so I'm going to get rid of that. That's just a 1 now. 2, 14 divided by 2 is 7. So really all I have to multiply together is 7 times 13 times 11. Ooh, a bunch of prime numbers. No wonder nothing canceled out. You get this awesome result of 1,001 teams or different combinations that coach can make for the track and field athletes. Alright, so there is a ton of probabilities here, and we're just going to keep practicing finding them. Now you got to decide whether a question represents a permutation or combination. So a subway car has 8 empty seats. At one stop, 5 people enter the car, no one gets off. How many ways can the 5 people arrange themselves in the 8 empty seats? Does it say anywhere anything about Bob has to sit next to Amber, or Bob takes up 2 seats? No, it doesn't say anything. Maybe he has a backpack with him, he wants 2 seats, nothing. So the order doesn't matter. So what I mean by that is this is going to be a combination. So at one stop, 5 people. So 5 people are choosing out of 8. So I go 8 factorial over 8 minus 5 times the 5. So this is going to be 8 out of 3 out of 5. 5's bigger. So I'm going to go 8 times 7 times 6 over 3 times 2. Notice this 5 I'm canceling out, right, with the rest of these. So these 5s are canceled here. 2 for 1, 3 times 2 cancels with a 6. I'm going to have 56 ways they can arrange themselves. Right? So you have to pay attention to those numbers. Let's try this again. A history test. List the name of 5 presidents. And each student is to choose 2 of them to compare in an essay. How many different pairings are there? So I look at that. How many different pairings are there? Does it say males have to go with females? Alright, there's no female presidents yet. That one doesn't work. Does it say anything about last name combinations? I'm going to go with combination again. Alright, I think how many different pairings are there? So they want to know A and B, B and A. Okay, that was the combination that we started with. So you got 2 and 5, so 5 choose 2. So guess what? 5 minus 2 is 3, and then 2. So then you're going to have 5 times 4 times 3 factorial. This is going to be 3 factorial. 2 factorial. 3's cancel. 5 times 4 divided by 2 times 1 is going to be 20 divided by 2, which is equal to 10. I know this one is exactly correct because at the beginning I did 5 basketball teams and they had to play a game and matched them up with 2 and I got 10. So this is a pretty good review. And make sure you're confident that your answer is correct. Surveys ask people to rank basketball, baseball, tennis, soccer, and football according to how much they enjoy watching each sport. So I see that there's 5 of them by the logos. Your ranking. Rank should trigger or should really tell you that this is a permutation. Order matters. First is different than second. So I go 5p2. So then it's going to be 5 factorial over 5 minus 2. So that's it. You're done. You don't have to do that 2 again. So this is going to be 5 factorial over 3 factorial. So then it's 5 times 4, right? is 20. Remember, this is 3 factorial. 5 times 4, 3 factorial. Those are canceling out every time. Right, so that permutation is 20. Ooh, I screwed this up. Why did I do 2? I shouldn't have done 2. That doesn't make any sense to me, now that I read the problem. This permutation is 5. So this is 5 minus 5. And now what happens here is you have 5 factorial over 0 factorial. 0 factorial, star this for a second, that is going to equal 1. So 5 factorial, so then 5 times 4 is 20 times 3 is 60 times 2. This is going to be 120 possible responses. So looking at that, I'm not sure why I did 2 right away, but there was no specific order that you needed. So you are just good to go with 5 minus 5. Any combination works. Alright, then there are 20 students in the speech club. 3 of these students will be chosen to represent the school at a regional competition. How many different groups of 3 students can be chosen? So this is worried about the different groups of 3. So 3 of these students will be chosen to represent the school. So you have 20. So this one's going to be combination. It just wants to know how many different groups could there be. So 20 choose 3. So I would have did 20 factorial over 20 minus 3 over 3. So this is going to be 20 times 19 times 18 times 17 all the way to 0. Well, good news. 20 minus 3 is going to be 17 factorial and 3 factorial. So we luck out right here because this 17 factorial will cancel with all those 17, 16, 15, 14, all the way down. So then I would take this 3, scribble it out, do 3 times 2. 3 times 2 is 6 still, and that 18 would change to a 3. So all I need in my calculator is 20 times 19 times 3. That'll be 60 times 19. You should get 1,140 ways that a team of 3 can be chosen out of 20 people. So, big numbers there, alright? But if you can figure those out accordingly, then you're going to be just fine. How many ways can the letters in the word combination be arranged? Hint, hint, we did this in the permutation video. We didn't do it today, so it's a specific one. Now, letter-wise, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is 11 factorial, divided by. If you remember yesterday, we are worried about the ones that repeat. So, ones that repeat. O and O, that's 2. Right, if I look for another one, these I's, well, there's not an I there. Right, this I, and this I repeat, so that's 2 factorial. And then if I look for an A, an N, and an N is 2 factorial. Sorry, I don't know what happened on this video, but can't talk. So, 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. All divided by 2 times 1, 2 times 1, 2 times 1. Alright. I'm going to let you in on a little secret here. This is not the best way to do it, so get rid of that 2. Cross the 2's and the 1's off. Cross this 2 off. Cross the 4. Make it a 2. Never mind, I'm just going to cross that off. Now I have to do 11 times 10 times 9 times 8 times 7 times 6 times 5 times 3 in my calculator. And exhale. So 11 times 10 times 9. I should rap in one of these videos and see if anybody actually listens to what I say. Alright, so we get a huge number, like 4989600 ways. Okay, so you have to be conscious of that. Now, the best way to do this problem is do 11 probabilities. Alright, PRB. Alright, then you hit enter. Right, that gives me some 39 million something. How many 2's do I have here? I have 1, 2, 3. So I'd probably just hit divide by 2, hit enter, divide by 2, hit enter, divide by 2. I actually, in my calculator, get this. So in all these other ones, when you're dividing by a 17, when this is going to come out to 17, it is easier to cross a ton of stuff off because you can notice top and the bottom to cross a lot off. But when you just got little 2s down here, all right, it's not going to be that helpful to cross stuff off. All right, it might be easier just to do it in your calculator. So you have decisions to make as to how you're going to multiply and divide these combinations and permutations out. All right, I didn't put the school quiz on Schoology. Come up to me and ask if you have questions. Otherwise, you are on your own, and have a good day.